Welcome to 5.2 Hess Law. These are the objectives. And this is Hess's law. In a chemical reaction, the total change in chemical potential and enthalpy, energy, must equal the energy lost or energy gained by the reaction system. So just like you had when you had A is to B, where you have conservation of energy and conservation of matter, in the same way, if it takes C to D in order to get to B, there still must be a conservation of energy and conservation of matter. So it doesn't matter which way you go, it's still going to be, the energy change is still going to be the same from A to B. So if we look here, this is probably a bit clearer of an explanation. This is usually the enthalpy of the reaction, and this here could be several different ways. In this lesson we're going to look at enthalpy of combustion and enthalpy of formation, but we will look at other ways of doing the enthalpy of reaction in different stages. Okay, so here for problem 1 we have two reactions here, and what we want to get is carbon turning into carbon dioxide reacting with oxygen. So it's quite simple. You just add equations together and then you just add their enthalpies together. Then you can cross out the leftover reactants on either side. Now in some cases you may need to reverse the reaction or times the reaction by 2 in order to get balancing or getting chemicals on the right sides. The important thing with this unit is making sure you've memorized these definitions so you know when to use them and how to use them, which I'll show you a bit later. Alright, so standard enthalpy of formation. The most important thing here is that you're going from standard states to a compound, and of course it's 298 K and 100,000 pascals, right? And don't forget the word 1 mole too. So you need to memorize all these definitions because you could be asked them, but you also need them in order to work out the calculations. So here we have carbon in its standard state as a solid, hydrogen in its standard state as a gas. If you're trying to get methane, that's methane, you're going to have to know that before we teach unit 10. That will go to a gas, so that will give you the standard enthalpy of formation. Here again you have everything in its natural state before you can get this compound here. So this would be the equation for the standard enthalpy of formation for this compound. Going on to problems then. Calcium carbonate reacts with hydrochloric acid according to the following equation. Calculate the enthalpy change for this reaction. So in this one we're assuming we're going to use enthalpy of formation. So first thing we do is we work out what the equation is. So in order to do that we have to know the definition, and we know we're going from standard states to the compound. So we draw lines going to R and lines going to P. So in order to get from R to P we go in this direction. That gives us negative for the reactants and positive for products, so we know that our formula is going to be delta H of products minus delta H of reactants. Okay, it's important you do that each time so you don't get confused on the formula. We then write out all of the different values. Always do your prep work so you don't make the small mistakes that will stop you getting 100%. Then we work out the delta H of the products, write out the different compounds with the correct moles, and then sub in the values to get minus 1,476 kilojoules. Do the same thing for reactants, write them all out. You'll see that we have 2 moles of hydrochloric acid this time, so we have to times that enthalpy by 2, and that gives us minus 1,541 kilojoules per mole. So we write the equation out, sub it in, and we get 75 kilojoules per mole. Problem 2, calculate the enthalpy change for the burning of 11 grams of propane. Again, write out your chemical equation if it's not given to you already. It's done here. Then we have to work out what the formula is. So because it's enthalpy of formation, standard states to compounds, so we draw the lines to the compounds, reactants and products. So we know the formula is products minus reactants. Write out all the values, and then first work out the products, times it out by the number of moles for each one. That'll give you 2,150. Do the same thing for reactants, write out all the values so you know how many moles to times for each one, minus 104. So the final formula gives you 2046 kilojoules per mole. Now, because you haven't actually used 1 mole, you've only used 11 grams, you then have to use number in moles equals mass on molar mass. That gives you 0.25 moles times that. So that one formula really equals Q. That's that Q formula, or delta H equals Q divided by N. Rearrange that, times it out by the 0.25 moles, and that will give you your 511.5 kilojoules. Okay, so the next definition that we're going to have is the standard enthalpy change of combustion. Very important to know what this is. Always 298 Kelvin, 100,000 kilopascals, standard states. But this is really combining with oxygen to form a compound. So you see here, graphite as a solid, reacting with oxygen gives you carbon dioxide. This one here is reacting with oxygen from hydrogen. These ones here are all reacting from hydrogen. Alright, so we know that we're combining with oxygen to create a compound. Problem 1, how do we work out the formula for this? Because we're using standard enthalpy of combustion here, we have to know what that is. The formula itself is giving us the enthalpy of formation. So what we have is these things being burnt. So what we have is carbon, hydrogen and methane forming oxygen compounds. Alright, so we're going to get carbon, hydrogen to an oxygen compound, and then we're going to reverse it, get the carbon out. So what you have here, a formula, is the negative direction for the products. So delta H here will be reactants minus products. Okay, don't forget to do this each time in order to work out what the formula is. So there's 2 moles of hydrogen there, so make sure we've times that by 2 for our reactants. Take it from our products, that's just 1 mole, so that gives us a final value of minus 76 kilojoules per mole. Finally, there's a summary here. Again, I've showed you in the video how to work these out. Don't memorize these because you'll forget. Alright, I'm very anti-memorize. We work everything out using logic. Alright, the only things that must be memorized are standard definitions.